about that later. This is really just syllabus stuff and not too important.
Okay.
All right, Section 7, Conduct Policy. Now, remember, this is a community college, so a lot of the policy is really necessary to spell out everything. That you guys work for the state, and a lot of times, these items, really do not need to be specific because you know this already from work. So I'll just kind of go over this really quickly. Um, Unintentional distracting behavior is not a good thing, but since we don't even have a classroom, so people can basically distract themselves on their end without affecting the whole class. So as long as it doesn't affect the whole class, I wouldn't know about it, and it's okay. All right. So intentional behavior causing confusion, fear, intimidation, or discomfort are definitely big no-nos. So if it is something that seemed to be just a slip of something, I might just have a word with the person. But if it is really intentional, directly to a person, you know, trying to cause certain negative impact on that person, I might have to refer that person to the discipline officer on campus. 7.3 is violent or other dangerous or endangering behavior. That would definitely be a no-no. I mean, if it's on campus, obviously we can understand what possibly can happen, what action can be in this category. But even if it's online, there are still things that people can possibly do. Have you guys heard of the term swatting? SWAT, swatting? No. I'll take it as a no.
No.
Okay.
No.
No.
I'll
Yeah.
take it. Oh, okay. So do you want to explain that, Loop?
Basically, it's kind of setting up an event, uh, saying that there's an event going on at a particular place. That basically you send the SWAT team to someone's house. So cops come with guns and stuff like that, and the person's just sitting there watching TV, and knows nothing what's going on. That's just setting someone else up for doing something like that.
Exactly. Thank you, Loop. So that happens usually to video gamers because they want to distract or disable a team from being able to play. So they will basically tell things to law enforcement, and it will trigger the local PD to send a SWAT team to basically a household with opposing or competing video game players, so that the whole event would be interrupted by the SWAT team trying to knock down the door. But it is also potentially dangerous because when people do not expect these things to happen, they might respond in a way that the police may think, okay, you're endangering me, because remember these police officers are going in thinking that it is a very dangerous situation. So anything can trigger the police officer to respond in a way that can be deadly. So I'm just using that as an example of 7.3, even when we are just on the fully online mode. Whew. Okay, so we are getting onto section 8, first day of class or orientation. Good job, all of you are here. So I have no reason to drop anyone. Okay, very good. Accommodations. If anyone has any type of disability and need accommodations, you can contact the DSPS office on campus. Even though we are doing everything remotely, they will still be able to arrange real-time captionists, translators, and so on. Um, and I do understand this is a Section 508 issue, which basically means everything should be accessible without someone requesting for accessibility. But the reality is the college only has so much money. They can't afford to have a real-time captionist for every single class that happens. So if you do have a disability, you can contact the DSPS office for accommodations. Excessive absences has to do with 6% or more absences. Any absences there are 6% or more is enough it's enough reason to drop a student from the class. And we are not face to face, we are online. So I would basically take roll, using Zoom. Zoom is great, okay, because I can look at the participants window and I can say, oh, okay, everybody's here, so I don't have an issue with today's lecture. Um, so not really a whole lot to talk about, other than I can use just the participants window to make sure that people are here, during the lecture. Um, I cannot do this with some of my other classes. Can anyone guess the class size of some of my other classes? Go ahead.
50?
60.
60?
Yep.
Wow.
Yep,
Is that just
60.
because it's online now and you can have more?
It's because that class used to be it's a double lab section class, so it's a single lecture but two lab sessions. The lab fits 31 students, so with a double lab, you have 62. But because it is online, we thought, hey, there's no actual occupancy restrictions anymore. There's no fire department, coming into the classroom, go like, hey, you guys have too many people in this classroom. So we upped the enrollment to 35 people per lab. So it started off with 70 students in that class. So you can probably imagine in that case, I'm not going to use, the participants, tab to see who's here and who's not, to basically keep track of row. But in this class, since we only got 5 people, it's not a problem. All right, section 11 talks about absences. Absences. There are two types of absences. It's either excused or it is not excused. If it is an excused absence, it's usually because of health issues. But if you have any reasons, official reasons, this really doesn't apply anymore. Athletic events, because we are not doing any athletic events. Um, but on the other hand, if you have some kind of summon from a court, because of jury duty or anything like that, that will also be excused. And personal sickness is also going to be excused. The unexcused absences would be basically everything else. So by default, all of the other types of absences are not excused. It doesn't really mean that I'm going to stick to this and really count every single one of these unexcused absences. So I do understand things happen. I have kids, so if they're sick, I can kind of understand that if they were still like when they're young, I might need to take a day off. So I do understand that. Late policy is quite simple. There's no late policy, so everything has to be turned in on time. Now I do leave at least 2 days, for work to be done. So it is important to kind of time yourselves and make sure that you have enough time to get everything done. Section 13 talks about academic dishonesty or integrity, depending on how you look at it. So basically, in my classes, I look at academic dishonesty whenever there's an attempt to show, okay, I'm just going to highlight the portion here, to show possession of a level of competency, knowledge, or skill beyond the level of the student. So that's basically the bottom line, is an attempt to show competency beyond the actual level of a student. So the means is not important. It really is, uh, the intent, what it is intended to do. The flip side, to look at this in a more positive way is to look at it as integrity. So in terms of integrity, the grade of a particular assessment of a particular student reflects the academic performance of the student and only of the student who turned in the assessment work. In other words, in this class, I'm not going to have group work. I understand at work you do. Okay, I understand at work you do work as a team with many other people. But when we are taking a class, the grade is reflective of only the person who's taking the class, especially when we're talking about something that is technical like this class. And there's also a whole bunch of other conditions here at the scheduled time of the assessment, following all the rules, and using only the resources that are permitted by the instructor for that particular assessment. So I'm pretty sure, well, I'm fairly sure that everybody understand what is academic dishonesty and also academic integrity. But in case there are any questions, let me know, and I can help clarify what is what. Moving on. A lot of this stuff, really does not apply to this class, because this is an apprenticeship kind of class. So you're more than welcome to read the rest of section 13, which I think is kind of important that you kind of read the whole thing, but I'm thinking that in the first lecture we can skip some of this, and I don't have to present it. Student rights and responsibilities is a really kind of important document because I know you're taking this class because of the apprenticeship, but if you want to take more classes and something happens and you want to know what your rights are, this is a really useful document for that. Section 13 is almost a repetition of an earlier section that talks about distracting behavior and stuff like that. So I'm not gonna get into this one, especially because a lot of these items are applicable only in a face-to-face mode. Section 16 is sort of important, how to attend lectures. First of all, this is online, okay? So if you do have a question, make sure that you let me know that you have a question. I don't have a problem whatsoever with stopping the lecture and address whatever questions or issues or whatever concerns that anyone has in the class. So go ahead and just let me know. With today's lecture, the quickest way to do it is to use the participants window, and you can, let me see. I thought there's a raise hand raising kind of feature, but I can't see it. Or you can use the text channel. So just go ahead and use the text channel to let me know that you have a question. And yeah, go ahead.
Oh, under reactions, if you click on reactions, there's a raise hand button.
Under reaction.
Do you see I just raised mine on my...
Yes, I see that. Huh.
Yeah, so
Okay, so let me show you my window. Okay, so I can see up, thumbs down.
Oh, it's on the bottom of the screen. It says participants, chat, share screen, and reactions.
Oh, okay, I
and
see.
And then under, or maybe it's somewhere different on yours, but mine's on the bottom. And then you click on that and it has a hand raise.
I'm taking a look at, because I'm presenting, so when I present, the usual Zoom window goes away. It becomes a little tab thing on the top. I'm not going to raise my hand, so it's not going to be an issue. So it's really for the most for the rest of the class. But so thank you for letting me know how to do that, and I'll be keeping an eye on raised hands and stuff like that during the lecture. All right, great. I'm getting a ding, and interestingly, we have 2 people watching from my YouTube channel. So I think those are my other students. Funny. Or maybe they just turned it on and forgot to turn it off. All right. So, oh right, how to attend lectures. So this is kind of important because I do record the entire thing. So it is being recorded right now. It's being streamed to YouTube as we speak. So that means there's no need to frantically write down everything that I say or everything that I do on the screen. As long as you can see it within the screen here, it is actually being recorded as we speak. So I don't even have to upload a file later on. It is actually being DVR'd right now. So that means you, instead of trying to write down everything that I say, you can jot down notes that are important to you. In other words, what you're thinking, how you're relating the topics, the concepts and whatnot, that you might want to write down, right? Because that's not going to be recorded in the DVR on YouTube. And I'm pretty sure Google would like to be able to read your thoughts so they can record that too. Fortunately, it doesn't have that technology yet. So we don't have to worry too much about Google recording your thoughts just yet. But trust me, that day will come. Okay, nobody is laughing, but I am. Because,
I was on mute.
okay, so the reason why I'm chuckling is because have you have you guys heard of the IBM Watson project?
The
No.
AI
Oh,
project.
Yes, the AI project. So Loop has heard about it. So I'll
Artificial
just
intelligence.
yep, yep. So
They,
Watson.
yeah, they put them. Didn't they have a Jeopardy challenge where they've had people play against Watson?
Yes. So that is how it got its fame, but it is more than that. So if you look up, on IBM Watson products, it's basically an AI engine, but it's not an AI engine in the same sense as a neural net, which is kind of what people equate artificial intelligence to. Is oh, it's a neural net. You have to train it 20,000 times, then it can start to recognize stuff. Okay, it's not like that. Okay, IBM Watson is not a neural net based type of AI. It is actually capable of doing symbolic processing, and that's why it could play the Jeopardy game and beat human players. And those are top tier champion type of human players. And this IBM computer, which had no internet access during the game, was able to beat everybody. So that was kind of interesting. You can also look up, this is also quite interesting because it says IBM Watson personality. Okay, this is going to be fun. Personality insights. There we go. So if you click on this link, let me see right there. Now, obviously, I'm distracting myself right now. In other words, I'm kind of doing something that I said we should not be doing, but I think it is related to this class, even though it is remote. Okay, but it does relate. Um, so the personality insight of Watson. Okay, they changed the. I think they changed the interface. Now it requires. Maybe I click on the wrong link. Um, get started free. No, I think it gets me to the same place. So anyway, it has an interface where you can submit writings, either your own or somebody else's, and it will do the Ocean personality assessment based on the writing that you submit. It's really interesting. So for those of you who want to understand more about personalities, which I think is a good thing,
hmm
that's a very interesting way to assess your personalities. So I distracted, yes, I did distract, but I also did not distract because you might think, oh, that's some product of IBM, I really don't need to know about it. Well, guess what? You can actually link Watson reasoning to COBOL programs. Yep, they made it possible for really old-fashioned COBOL programs to interface with the latest technology that IBM has developed. So it's kind of interesting, right? I mean, that's IBM for you. Okay, they make everything connect, and everything is backward compatible all the way to the beginning. And we'll talk about that later today after we kind of finish this portion. I'm just looking at the time. You see me turning my head. That's because the clock of my computer is on the other side of the portion that's being recorded. All right. So to getting back to attending lectures, one thing that might be helpful, when we get to technical topics, is to keep track of time. And that is also why you see, okay, I have to move the mouse pointer here. That's why you see a real-time clock, in the recording too, because that portion is going to be recorded. So if you just write down the time when I start to talk about something that seemed to be important, it becomes an index so that later on when you watch the same thing on YouTube, you don't have to start watching from the beginning. You can jump right into that particular time frame so that it can save you a lot of time. Okay, so you might want to consider using a spreadsheet or a document to keep track of the time mark of when I start to talk about something. So that could be useful. Go ahead, Kelly.
Um, so these YouTube, the sessions that you're going to be recording, do we just look up your name and then the date to find the recording, or are you going to give us links for it?
That is a very good question. There are several ways I can do this. What I do with my other classes is something like this. Okay, so since we're also using the chat channel, I'm pulling the chat channel up here. So I'm giving you a link to YouTube. If you click on this one, you can do it now. I mean, it's kind of distracting to click on it now, but you can even click on it now, and you will basically be watching the lecture from the beginning.
Okay.
Yeah. So I can do this every lecture because it's going to be a different link, every single time. But I can also post a link just using the chat channel, so that way you can put it into a spreadsheet and you can track it. The other way to do this, if you in case you cannot remember and you forgot to kind of put that in, is to go to YouTube. The channel name is Some Profs, as in some professors. Okay. And then you press the enter key. Oh, you guys cannot see it. You cannot see my URL. That's okay, because it will show up here. So all you have to do is to type youtube.com/ and then some profs. I'll put it into the text channel too. So that will go straight to my channel. Once you get to the channel, you can click on videos. And once you get into the videos, everything is sorted in a reversed chronological order, which means the most recent item is at the top all the way to the left hand side. So this is where we are now. So this is where we are now. If you were to click on this one, youtube.com/ and then some profs. I'll put it into the text. So yes, it does sound like we're in a time loop for those of you who like sci-fis. But this is really kind of cool because you can actually go back to an earlier part of the lecture. And once you get into the videos, everything is the college only has so much money. They can't what action can be in this category. So this can be helpful, because in case someone says, okay, we need to take a break because it has been an hour already. We can take a break, and then you can go back to the video and go back to an earlier point to revisit something that you thought, okay, I want to revisit that portion of the lecture. So that is what I do in all of my classes, is to have the recording DVR'd to YouTube. And I think you can, if you can index everything by putting a time mark on at the important times, that will really help you to locate the segment of the video that you need to review quickly. So that's going to be helpful. All right.
I just want to say that's really
Absolutely.
cool.
Sorry, go ahead.
Yeah.
I really like that. Thank you.
Oh, you're welcome. Well, technology is, easy. It's pretty easy to do that now. I've been doing this for almost 10 years. So I have more than 2,000 clips on YouTube, and each one is 80 minutes long. Yep. And YouTube has not complained yet, so I'm not going to say anything. All right. So in section 17, it's titled "How to Succeed in This Class." So if you read on, it's really long. It goes on and on and on. So the bottom line, the executive summary of section 17 is, in my classes, I value the ability to understand concepts and also the ability to apply the concepts to solve problems. Now, obviously, that applies a lot more to my programming classes than this class. This class has a lot more focus on just the knowledge rather than problem solving. In a programming class, there's a whole lot more problem solving than there is about, okay, I just need to know something. Okay, I need to know what the abbreviation of this means and blah, blah, blah. But nonetheless, okay, that is the focus of my classes. So I'll get to this. I'll get back to this whenever it is applicable, so that we can kind of focus on the understanding of concepts and not just knowing something. So we'll get back to this later on. All right. So grading standard, don't read it. Don't read it just yet because I have to change my usual grading standard because this class is going to be co-taught by another professor. So there'll be a different professor for the second 4 weeks because we just got this professor. Um, and it takes time for a professor to learn how to use Canvas, how to teach a class for someone who has never taught a class before. So that professor is getting up to speed as we speak, right? And as a reason, that's the reason why I'm teaching the first half of this class, even though I really don't know that much about mainframe computers, but I can read, I can understand concepts. And then the second half is going to be taught by someone who has been using mainframe computers for a whole lot more years and know a lot more about mainframe computers, but that person had never taught at a college level before. So that's kind of what we are doing right now. And that is the reason why I want to talk to that professor first to talk about how to do the grading and stuff like that before I, kind of finalize and put it in the syllabus. So I hope you understand why this is still up in the air right now, the grading standard. So I'm not going to talk too much about the grading standard, just yet. All right. All right. So that's basically almost it. The last portion is the tentative schedule of topics. This is tentative with an emphasis on the tentative part, which basically means, we'll get to something when we get to something. Okay. Generally speaking, I'm fairly good at, catching up, when I'm falling behind a little bit and so on. But it really depends on how fast the class can, keep up, and how fast I can keep up too. Because remember, all of this stuff here is new to me. The concepts are not new, but the IBM terminology is new. The way that IBM does something is also new to me. So there's that too. But this is the tentative schedule, and you get a list of the topics that we'll be going over in this class. All right, so that's the syllabus. Do we have any questions?
Not at this time, I don't.
Okay. Does anyone need a break? Or does anyone want a break? All right, so I'm gonna guess that is a no. So now I'm gonna get into a portion that I really kind of enjoy talking about. That's the syllabus. This is easy, okay? Notes of tax. If you open it up, it goes to a Google Drive, a Google folder with all of the modules that I am going to write for this class. So this is where you can find all the documents that I am writing specifically for this class. The module number is, it starts at 334 because I have written 333 somewhere else. So I'm just sequentially, numbering the modules so that I can refer to which one and not having to refer to the long topic of that module. So the first one we're going to get into is this one here. It doesn't have a whole lot of pictures, because I don't do a whole lot of pictures. But we can Google search, as we talk about these topics. So are you guys ready to go, or do you guys need a break?
I'm ready.
You're ready? All right, I like
good.
that. Thank you. So we're going to get started here. And the reason why I talk about this, I can zoom in, in case you guys cannot read the text because the font is too small. We'll zoom in a little bit. There we go. And I have to watch out for my own face because I usually don't see it because when I focus on this part, I don't see the video, the webcam little corner of myself. So I have to be careful not to kind of talk about things that are covered by that portion. or we can zoom out just enough that that becomes a non-issue. Yeah, so right now it's not an issue anymore. There we go. All right. So the reason why I wrote this particular module is because a lot of things about IBM mainframe computers can look very strange and weird, and basically people would be asking, why would anyone do something like this, right? Because why do we do something like this? That's an important question, at least to me, okay? Because I cannot learn something just because, well, this is the way it is, okay? Just do it, okay? This is how you do it. Don't ask questions. I cannot do that. Some people can, some people cannot, and I'm just one of those people who cannot. So it is kind of important to understand where mainframe computers come from and why they are the way they are now. So this focuses on physical storage devices. In other words, how do we store data? And when we talk about storing data, we're talking about storing massive amount of data, like the census of the United States. Okay, that kind of quantity of data. So before we have all the magnetic or electronic media, we got punch cards. Okay, so that's what the card part is mentioning, is basically punch cards. So if you don't know what a punch card looks like, you can look it up. Okay, so you can just look up punch card and go to images, and there are plenty of examples. You can go to Wikipedia and just kind of look up what are the variations of punch cards. But no matter what punch card you're using, or whichever one you refer to, it looks kind of like this. It is a piece of paper, and it has columns, it has rows, and what we do to store data is to basically punch holes. Okay, we punch certain holes, and it will be used to to store data that way. All right, so that's what a punch card looks like. So that's basically the first kind of mass store that we have for mainframe computers, and that's yeah. Go ahead.
Sorry. Is that date correct? The 1990 is when they started being used, or is that supposed to? Because then it goes into 1928, 1964. Or is that supposed to be 1890? Or
That is supposed to be 1890.
oh, okay, I was thinking it seems like it's been longer than 30 years.
You're right. Thank you. So this is
Okay.
why it's good to have a living document, because I can just click change it right away. But thank you for letting me know.
Okay.
It also has a little footnote. Okay, so if you're curious about that piece of data, you can go to the footnote, which usually has a hyperlink, and you can just kind of follow the hyperlink itself. If you're curious and want to read more about it. It's not required. Okay, definitely do not follow every single footnote, because you won't have enough time in the day to read that much material. So it was 1890, which is before IBM mainframes, computers came along, but it was used to store the data of the census of the same year. Which is interesting, because they did not have computers to process all that data, but they know that in the future, okay, there may be machines who can automatically process the data, because they're only concerned about storing the data for the time being. And I think the law only requires them to acquire the data and store, and I don't think it requires them to have everything processed by a certain date. And IBM started to use its own punch card formats in 1928. So 1928 is what? Close to 100 years ago, right? It's 93 years ago. That's a long time. That is a long time ago. And what is interesting about punch cards, which you'll read later on here, is that actually determined the format of a JCL a JCL file, or a JCL card, as they say. It's coming from a punch card. Why do we start with slash slash? It's because of easier to be processed as a punch card. Why do we start with a particular column for a certain thing? That's also because in a punch card, that's easy to remember, and also earlier mainframe computers only have so much processing. They can't really do the parsing that we can do today with a modern programming language. So many things that we know about IBM mainframe computers, many things that you have to do with modern IBM mainframe computers, traces all the way back to 1928 when they were still using punch cards. So you might say, well, maybe they just stay with punch cards for 10 years and then we move on to something better. Nope, that was not the case, because in 1964, IBM introduced EPSIDIC punch cards. Because before EPSIDIC, punch cards are mostly used to store numerical data and not so much with alphanumeric data. So it would be kind of difficult to store an address without being able to spell out the names of a street, the name of a city, and so on. So it's only in 1964, which is, I'm just trying to do some quick math here, 36 years. Okay, so 36 years after they started to have their own punch card format, they started to introduce alphanumeric data to be able to be specified by punch cards. And eventually, 8-inch floppy disk, obsoleted the use of punch cards in 1973. So punch cards basically were used as the mass store device or mass store media from 1928 all the way up to 1973. That is a long time. Okay, we are talking about close to 50 years, 45 years. So, are there any questions about punch cards up to this point? Okay,
No.
no questions. All right, cool.
I do have just one real quick one.
Yeah,
So
go ahead.
because they did the EPSIDAC, the way that it's the punch card, and I'm just confirming this. This is what I'm thinking. The punch card's laid out in columns. It would just punch out the EPSIDAC number of whatever character it wanted in that particular place.
I don't think that is the case.
Okay.
With EPSIDIC, it is a way to binary code letters. So if you are to look up EPSIDIC, EBC, EPSIDIC. Oh, there we go. EPSIDIC. Okay. Great. Well, Wikipedia never fails, so let's go there. Okay, so EBCDIC stands for Extended Binary Coded Decimal Interchange Code. Yes, that is how IBM likes to name their stuff. Um, it's an 8-bit character encoding, which means it is actually a competing standard when it comes to ASCII. Okay, so it is competing with ASCII, as in how should we encode um, letters, punctuations, and stuff like that. So when you look at the layout, okay, this is a punch card that enters, EBCDIC information. So basically, from bit 0 to bit 8, bit 9, I think is used for some other reasons. So each column is representing a character. So you kind of have to look into uh, the binary representation, based on EBCDIC, and you can see what these are the actual characters being encoded for each column, and the below portion here is the actual representation on the punch card. So I think that answers Loop's question,
Okay.
right?
Yeah.
Yeah.
I
So
mean, kind of. Yeah. What I was thinking is when you look at the EPSIDIC table, it has a number associated. Like you can use, I think you can use the Alt keys to type in, like if you wanted to type in like registered trademark or something like that, you just do Alt and the keys to punch that. I was just thinking that on the card itself, if A was like 65, like it or whatever it is in ASCII, um, that it would actually punch then that number into the punch card to represent it, but it doesn't look like it's matching that.
No, because that method has a very low data density, so you will need a whole lot more punch cards, than this particular format. This is the binary coded format, and it's more dense in terms of how much information you can fit onto the same punch card. And in this case, you can see on this specific punch card, all it is encoding is from 0 through all the uppercase letters, some of the punctuations, and ending with a period. That's all that you're encoding on this particular punch card. So one punch card translates to about one line of text. Can you imagine that? I mean, just kind of imagine, one punch card is only about the same as one line of text. So if you want to store, okay, I'm not sure, which one of you, do you guys work for, does anyone work for franchise tax board?
Yeah, I do.
You do? Okay.
Yeah.
So if you just think about the kind of data that the franchise tax board is collecting, and one card is only representing one line of text, how many punch cards are we talking about to encode, just the annual incoming amount of data that the franchise tax board has to process? I mean, the EBB, the board of the BOE is not any less, right? If anything, it might be more. The DMV also handles a huge amount of data, so that kind of gives you the perspective of where we are compared to even just 1964. Okay. So this is also interesting because the term dataset applies to basically a whole deck of punch cards. So when you look at a deck of punch cards that records some data, that's called a data set. So that is how these terms come around. Okay, what is a data set? Because if you're not in the mainframe business and you say, okay, what is a data set? Nobody knows. Okay, only people who work with IBM mainframe computers understand the concept of data set. And originally, data set refers to basically a deck of punch cards. Let's see. So this particular paragraph is also important, not only when it comes to storage, but also comes when it comes to what is batch processing, why do we do batch processing, and what is the reason behind batch processing. When your data is stored in these gigantic, huge decks of dataset, punch cards, can you switch from one task to another just on a dime? It's like, I don't feel like, doing, tax return right now. Let's go ahead and do tax auditing instead. If you say that, if you're the boss, okay, and you're telling your mainframe center operator and go like, we let's stop doing this. We would much rather spend the time to do this like right now. What do you think the data center operator is going to respond? Okay, so think about the perspective from the perspective of a data center operator, right? So you just finished, loading up a huge deck of punch cards to process tax returns. Just so that you can know who is owing the government how much money. Okay. Which requires the cards, a specific deck of card to be loaded in a certain way and a program to be loaded in a certain way. You just got a whole setup done, and the computer is flipping through all the punch cards in the middle of this process. The boss comes in and go like, hey, we don't want to do this anymore. I would like to do the tax auditing program instead, and figure out who is likely to have been evading taxes for the past 5 years. What do you think that will entail in terms of what you need to do as an operator? Well, you have to stop the process, right? You have to stop whatever the mainframe computer is doing right now. So the deck, the card reader is in the process of reading a gigantic stack of cards, and you kind of have to stop it. You can't stop that. Okay, because if you stop it, the cards may go flying in all different directions. And two, now you have to go back to the storeroom because the data density of punch cards is really low. So to load the historical financial records of companies for the past 5 years, you're going to have to go to the storeroom to retrieve that gigantic deck of card, load it onto the card reader, right? The program, by the way, is also specified by a deck of cards. Okay, so a COBOL program. So here's the question: how come COBOL programs can only have up to 72 characters per line? Can someone guess?
Because the punch cards are limited to 80 characters.
Yep.
And the last 8 characters are kind of a sequence number.
Yep. Exactly. Yep. So the COBOL program is actually originally a part of the deck of punch cards that you feed to a mainframe computers. So the job card is basically the first few cards that sets up the rest. And then it will get to the COBOL program. And then after the COBOL program, you get to the actual data set to be processed. Okay? So this entire thing has to be almost manually set up, okay? Because back then, I mean today, if you are to do this today and you want to be nostalgic and go like, oh, I would like to do punch cards and load these decks of cards, we have robotics today that can do some of this work. Okay, if you just look into Amazon and how manufacturers of automobiles can put things together using robots, we can probably automate a good portion of this. But remember, this is back in the 1960s. Okay, we did not have robotics to do this sort of thing. It has to be done by a person. So that means it takes a lot of planning to say, okay, what do we want to do with this super expensive mainframe computer tonight? It takes a lot of planning. It takes a lot of planning beyond just one day. Okay, because people have to plan out, okay, this job is going to take 3 hours, that job is going to take 2 hours, and we got this much time left, okay, overnight. So we cannot fit this 5 hour job anymore, but the 5 hour job is more important than the other two. So let's put the 5 hour job as the first job, and then we have a leftover of 2 hours. That's the sort of thing that the operators have to do. And that's why we have batch processing. It is not interactive. It's not on demand. It's difficult for us today to imagine that things have to be planned out. Just because we don't, right? I mean, these days, you can switch between apps on the phone just like that, right? Just swipe it and you get to a different app that's running at the same time. No problem. Not with mainframe computers, not in 1964. Okay, to switch jobs is almost, you can't do that. You just cannot. Okay, so that's why we have batch processing. So batch processing goes all the way back to the limitations of storing data on punch cards. So are we good so far with section 2? Just kind of getting an understanding of how the storage medium has an impact on how we process the data.
Yes.
All right, excellent. So section 3 says, okay, now we want to move on because punch cards is not really the best way to store data. We can have a higher density if we start to store data onto magnetic tapes. So that started to happen in 1952. So there is an overlap between the use of punch cards and the use of magnetic tapes. And by the way, magnetic tapes are still in use today, but not really so much for data to be processed. We don't process data directly coming from tape anymore, but we only use magnetic tape for backup purposes. We'll get to that point later on. So compared to punch cards, okay, I'm reading the third paragraph here, the second paragraph. So compared to punch cards, magnetic tapes are easy to handle because you don't have to worry about you know falling, and basically throwing a box of punch cards all over the place. Yes, as Loop just mentioned, each card is supposed to have a sequence number, so that if you do mess up the ordering of punch cards, guess what kind of machine you put it back into to fix the problem? Let me ask that question again. So let's just say that you're carrying several big boxes of punch cards, and then you trip, okay? And then the punch cards just went flying in all different directions. And then somebody helped you collect all the punch cards again, but now they're out of order. So what do you think you would be doing after collecting all those cards?
Manually sorting.
Well, at first they did. Fortunately, somebody invented a machine called a card sorter. You can look it up. I'm not making this stuff up. I mean, you cannot make this up. So if you just look up punch card sorter, you will find references. IBM card sorter. These are not small machines, by the way. I mean, these are actually pretty good sized machines, and they serve one purpose and one purpose only. They take a deck of cards that is out of order but has a sequential number on each one, and it will sort it back into order. That's all. That's all it does. Um, yeah, so we are talking about inconvenience because of punch cards. So magnetic tapes are easy to handle because you don't run into that problem. I mean, if you spill the tape out of a reel, that can also be very bad, but it doesn't happen as frequently. But they're still bulky, they're still kind of slow by today's standard, especially. So batch processing continues to be the only way to utilize the computational resources of a mainframe computer. So the switch from punch cards to magnetic tape to store the data to be processed doesn't really change the necessity to have batch processing. I mean, things go faster, it is more convenient, and we don't have to worry about the punch cards being out of order anymore. But it's kind of the same thing, okay? Because everything is still sequential, okay? Because a tape is a sequential medium natively, which is mentioned down here. Okay, so the physics of punch cards and magnetic tapes are different. One is paper based, and the other one is based on magnetic medium. But at the end of the day, they are both sequential. In other words, it's really hard for you to say, oh, skip forward, forward, and then skip backward, backward. Okay, I'm dating myself here, but back in the days when we had VCR tape, and your kid says, I really just want to watch that portion of the tape over and over again, what do? The more expensive VCRs can be programmed to only watch a portion over and over again, but there's a lag between the end, getting to the end, and then going back to the beginning, because it has to physically rewind the tape to the index where you want to watch again, right? I cannot use analogies like this with my other classes because nobody would understand. Because I got like 20-year-olds and 16-year-olds in some of my other classes, and when I mention VCR tape, they go like, "What? What did you just say?"
Or even like a cassette tape.
Or cassette tape. They don't have any concept of tape. The only tape they know is tapeworm, because social media goes like, "Oh, this person got some really gross tapeworm." Ah, tape. Okay, so that's tape. Yeah, I mean, they have no concept of what is cassette tape. Yeah. So, but anyway, we're getting back to the point that tape is also sequential. It's not random access. It's not like, I want to jump to that particular record all the way down there. You can, but it's going to cost you a lot of time. Okay. And the tape machines were not designed to do that either. So you can only go back and forth so many times before the tape starts to, guess what? Stretch. Okay, and when tape stretch, you have all kinds of issues too. So there are problems with tape as well. Now, the data density has increased, and IBM also designed and manufactured tape libraries. These things are still being developed now. I mean, you might think that we cannot be using tapes anymore. Nope, we're still using tapes. And the latest tape machines or tape libraries from IBM can store a huge amount of data. I think they measure in exabytes, exabytes, um, with a footprint of about 10 square feet. So that's a very high density, and that's why tapes are really good even today, is they have a really high data density, and they don't need energy to maintain that data. Um, okay, I'm just following my own writing here. So the tape library makes it possible to preload the system with more tapes than there are tape drives. So this is still true, with today's tape library, which basically means you can now store, all of the record, all of the data that any type of batch job, would need using a relatively compact appliance from IBM. But the problem is, in order to finish the batch jobs efficiently, you still want to kind of preload things and go like, okay, let's make sure that we order tapes in the right order, and then following the jobs. So this way we make the most out of a mainframe computer. Now back in those days, back when tapes, back when we process data directly from the tape, um, the tapes still need to be wound backwards a lot of times, because when you're done you might want to rewind the tape before you store it. So we did spend a lot of time just physically turning the reels of tape on the tape machine. So what do you think the mainframe computer would be doing while the tape drives are going like, okay, I need to rewind all the way back to the beginning? The mainframe computer becomes just a heater, right? Because it's not doing a single useful thing while the tape drive is just rewinding. And mainframe computers are expensive. They were super duper expensive, and they are still expensive by today's standard. So we don't want to waste resources like that. And so what happens is we usually have multiple tape drives. So when one is rewinding, we will basically have the other one ready to go. So that way, but once again, this is the reason why we have batch processing, because we have to plan all of this stuff ahead of time, so that when one job is done and the machine is rewinding, we'll have the tape of the next job ready to go on a different tape drive. So we have to kind of manage all of this stuff here. In 1950 something, there's no robotic system that can do all of this stuff here. So this is all done by people. So basically people have to read the job cards and find out, okay, what tape do we want to mount on which tape drive, so that we will be ready for the next job, along the list. That is also why we have batch processing. So even though tape is a whole lot better compared to a whole deck of punch cards, it doesn't change the nature that we still need batch processing. All right, so now we move on to something that we are familiar with. Okay, so we are familiar with hard drives. Okay, our generation, my generation, is familiar with hard drives. And the interesting thing is IBM actually invented the concept of a hard drive. It was not the other companies, it was IBM who invented the hard drives. So the hard drive concept was introduced or invented in 1956. So it does overlap with tape drives too. And that evolved to what we now know as RSAD, or Random Access Storage Device. Does anyone know whether there's an acronym to pronounce RASD, or is it just kind of spelled out with the letters? Okay.
I haven't come across that acronym in my other reading. So.
Oh. Okay. So this is a rather important acronym or abbreviation. RSAD, RASD. Okay, I just messed up. So RASD stands for Random Access Storage Device, which to the rest of the world is known as a hard drive. But IBM does not refer to it as a hard drive. It just says it's a RASD.
At my work, we use the DASD, Access Storage Device. So maybe
Direct
they pronounce
access.
they yeah maybe they pronounce this as RASD
Okay,
because we
that may be.
pronounce that DASD.
It's
So
also
I don't know,
possible. Yeah, it
but I
might be
haven't
possible
heard
that
this
I just
being
messed up
used.
here too. Maybe
No,
it is
no, I
direct access and not random access.
no, that's probably a different one.
Okay.
I don't know.
I
She's
might
just
have messed.
comparing it to
Like how they
DASD.
say it,
Say
yeah,
it. So
Yeah.
it'd be RASD for
RASD or
random
DASD.
acts. Yeah.
Yeah, I know, but now I'm obsessed with, knowing whether I made a mistake or not.
Oh, okay.
Oh,
Yes,
well,
I'm
right up at the
obsessing.
top there was RASD, DASD next to each other on the top of your search.
Sorry?
I would actually search the random access storage device
Oh,
and see
there's
if it comes
RASD,
up with an
DASD.
acronym.
All right. So IBM has direct access storage device, and does it have a RASD? Nope, it does not. Okay, so I stand corrected.
Oh,
There is on the fourth link down. It does have the acronym RASD in it. That third one, there you go. The fourth one as well, but I don't know what the contents of it is.
Yeah, I don't think it is random access storage device.
I feel like I've heard that though before. I feel like
Me
I've heard
too.
Oh, okay.
random.
So,
Whoa, wait. Random access. Maybe
okay,
I'm thinking of RAM.
I'll make a note.
Because DASD is direct access.
Mm-hmm. Which basically means the same thing. Direct access and random access in this context probably mean the same thing. So look this up. So this way I don't forget to do it. There we go. All right. So, but we are talking about hard drives, and what hard drives are. Okay, we don't have to get into the actual details, but basically what you have is a stack of rotating platters, and for each platter it has a top and a bottom. So there's one disk head for each platter surface. The disk head would do the seeking, which means it can go um, basically goes along the radius of the disk while the disk is rotating. So this is how you can basically read a different sector by moving the disk head onto the track and then wait for that sector to rotate under the disk head so that you can read the content on a particular sector. So that's kind of the physics of a hard drive. And the best thing about a hard drive is it does support random access. In other words, you don't have to read things sequentially anymore. It is relatively efficient to read things, not in sequential order. So this is a big thing. It is a very big thing because it made a lot of things possible. And I'm going to fast forward a little bit here to this portion here. So I'm going to focus on this particular paragraph. And basically, once we had hard drives, the necessity of batch processing is not completely removed, but a lot of the inherently batch-oriented characteristics of sequential access media are overcome because you are no longer reading a tape nor a deck of cards. Now you can actually move around and go like, I feel like accessing this data now, or I feel like accessing that data now. You can actually do it pretty much on the fly. In modern day, okay, this applies to modern day hard drives and storage technology. So let's just say that one hard drive is not enough to store all the data that you need to store or process. So what are we going to do? Well, we have a lot of different technology to combine the storage capacity of multiple drives into one single logical entity So let's just say that you have okay, personally. Okay, so this is for personal use, not for enterprise use. So personally, let's just say that you take a lot of pictures, and you go like, I need 6 terabytes of storage to store all the movies and all the pictures that I have taken. I mean, that's a lot, okay, even for someone who takes a lot of pictures. But let's just say that is the case. And let's also just say that each hard drive can only store 1 terabyte, which I know is not true, but I will just make that assumption. So what are we going to do? Because one drive can only store 1 terabyte, but you need a combined storage capacity of 6 terabytes. So what we do is we use technologies like RAID, R-A-I-D, okay, which is only one of the many technologies available for doing something like this. So what you do is you end up buying 10 drives. So you might say, well, that's overkill because now we got 10 terabytes, of which we only need 6. Well, that's because we also want redundancy. In other words, of the 10 drives, we can afford to lose like 2 of the 10, and the system as a whole will still be running, and it won't lose any data. So that's the beauty of RAID, RAID, which stands for Redundant Array of Inexpensive Drives. So that's the kind of thing that we can do with hard drive technology. It also, because of this, because each hard drive has a high data density, so we can potentially store everything that we need to access without the need to use tapes anymore. Now, whether that's doable or not really depends on the volume of data that your organization or agency is dealing with. Does anyone have any amount that you know of? Like with the DMV, do you know how much data that they have to store? Or with the franchise tax board, how much data are we talking about?
I know you're looking for a number, but lots. That's about as close as I can get.
Or that's funny.
Yeah, because it depends on the order of magnitude. I can give you an example of why it depends. Okay, so let's just say that this is once again a personal use of storage devices. And this is back in a different time, okay? Back in a different time, when the largest hard drive was, let's just say, 100 megabytes, okay? And I know, it sounds, by today's standard, it's like, what are you talking about, 100 megabytes? My SD card has almost a gig, right? So back in those days, okay, your hard drive can only store so much. So what if you have a lot more to store? You kind of have to use tape, um, as a library medium. Okay. In other words, if you don't need it right away, it is stored on tape. But when you need to get back to it, then you load the data from tape back onto the hard drive so that you can do the processing on the hard drive. When it's done processing and you go like, I don't need to see this for the next 6 months, then you put that data, you put those files back onto tape, and you put the tape back in the library so that your hard drive doesn't need to store all the data that you don't need anymore. Okay, so that used to be the case for a lot of things, even for personal use. But today, with the capacity of hard drive that we have, that need is pretty much gone. Okay, and I can only imagine for agencies, for government agencies, that is also going to be a trend. Okay, because even with the franchise tax board, I don't think they have to store exabytes of data, not even close, because it doesn't have to store video data. It doesn't have to store a whole lot of audio data that I know of. Okay, because I don't work for the franchise tax board, I don't know how much data they actually store. But if they can store everything using just hard drive or SSD technology, there's no need to use tapes anymore, which also means it is now possible to keep all the data online, ready to be accessed all the time. There's no need for an operator to go back to the back room to find the tape that has the data, preload it onto a mainframe computer so a job will be ready to run when it is time to run the job, because that data is constantly all the time available. Okay, I cannot I cannot tell whether that's the case or not, but I'm thinking that is a continuing trend, which basically means more and more agencies will no longer need to deal with tapes, because the DASD or RASD is has enough capacity to store everything that needs to be accessed.
I don't think we use any tapes at the data center anymore because everything's on DASD, and now they're actually replacing DASD with flash drives.
hmm And
Yeah,
interestingly,
we save about at FTB we save about 3 tapes a day of backup for disaster recovery purposes.
yep.
Uh, and then, but we have a machine that automatically loads tapes for us.
hmm
But a lot of the tape, what we call tape right now, is the SSD, solid state.
Oh, that's interesting. That is interesting. I did not know that because IBM actually still makes tape drives, actual real tape drives, and also tape cartridges. Um, because I think okay, so this is so Loop. Thank you for that point. If you look at the capacity of an IBM modern tape, okay, so we look up IBM tape cartridge. Okay, these are the modern ones. And if I just click on one, LTO7 is not even the latest standard. I think the latest one is -9. But this is an actual tape mechanism, and I just want to look up the capacity of this thing. Okay, which is down
6
here.
terabytes.
Yeah,
Up to
so 6
15.
terabytes for the packaging that we are talking about. So I think this still has a better data density in terms of how much volume that we need to store, that we need to take to store the amount of data that we are talking about. It is also at a better price point because a 6 terabyte. I mean, if you want to use SSD to store 6 terabytes, it's going to cost you quite a bit more than $50. I looked up the
Yeah.
prices. So for consumer SSDs, okay, if you just go to Fry, okay, Fry's doesn't exist anymore. So if you go to if you go to a online merchant and you say I want to buy a 1 gigabyte SSD, that's going to be about $100. Okay, but if you say I'm an enterprise, okay, I'm the government, okay, I want enterprise level SSD. That's going to cost you more than $200 for 1 terabyte. So 6 terabytes is going to run you at about $1,200 as opposed to $50 for tape. So this is one of the main reasons why we still use tape is because it is cost effective. Because at the end of the day, the tape doesn't get reused. Most agencies do not reuse their tape. So they would basically do the backup, transport the tape off-site, put it into a big safe, make sure everything is cataloged, organized, and it's going to be locked away permanently. And it's not going to be reused. So no one is going to get to the safe and go like, hey, this tape here is 20 years old. We don't need this anymore. Well, there are 2 reasons why they don't do that and reuse the tape. The first reason is probably regulations, laws that basically says you cannot lose that data. Okay, you have to maintain that data all the time. That's the first reason. The second reason, let's say the law says, oh, you only need to maintain, let's say, 10 years of 10 years of data. Okay, after 10 years, that data is no longer needed. So now you take a 10-year-old tape from the safe and try to reuse it. What kind of problem do you think you're going to run into? There'll be 2 problems that you're going to be running into. What do you think those 2 problems may be?
Tape will
Material
probably
quality.
become brittle
Yeah.
Right.
with age.
Exactly. So the first problem has to do with the tape itself because it's made out of plastic, except for these new ones which are lithium based. So the first problem is, well, can we still count on that tape being usable at this point? It's probably still usable because after all, it is a backup, kind of medium, right? Because so it's probably still usable after 10 years, especially if the safe has climate control and stuff like that. So that may not be a big issue. But the second issue is, do we still have a drive that can read it? Because
Right.
things change really, really quickly. So in 10 years, it is possible, it's entirely possible that a tape drive doesn't, you may not even have that drive anymore. So now you might be asking, so what is the whole point of backing up data onto a tape when there's no way to read it back after 10 years? Well, you can read it back, okay? And this is one of the things that makes IBM different from Microsoft and many other companies. You can always go back to IBM and say, hey, I got this ancient tape all the way from 1960. We don't have a drive to read it anymore. And IBM would say, don't worry, okay? You signed up a contract with us, we'll take care of you. So IBM will find a working tape drive to read your 1960 tape reel, if that is what you need. So it will still be doable, but it's going to be not very efficient anymore. And it's not going to be cost effective either. To reuse that tape, it's not going to be cost effective. So this is why tapes are basically considered consumable when it comes to being a data backup mechanism, because we do not reuse. And that's also why the price point is kind of important, because if you crank out, like, I don't know, 100 terabytes per day, that adds up pretty quickly in terms of how much money you need to spend on tape versus SSD to back up that data.
Yeah.
So there we
We
have it.
actually do use it every day at CDT. We use it mostly for disaster recovery, and actually I had to go in today and learn how to scratch some tapes for Veterans Affairs that they realized they were being charged for from the 1990s, and they didn't
Wow.
want them anymore, so they sent in a request to have us scratch those tapes, but we still use it regularly for storage.
So you reuse the tape?
I'm not. I'm still learning what they're going to do with it after they scratch it, but they were scratching the data off of it, and so
Okay.
they just did a whole IBM configuration. They just redid it and probably went with this new, what did you call it, Ultrium
Mm-hmm.
tape, and switched it over. But I'm still learning about that. But we have a couple people in our storage unit that specifically do all of the tape
Wow.
storage. Yeah, so
Well,
it's
scratching a
pretty.
tape is not the same as reusing a tape. Yeah, scratching a tape, I think,
It's like
refers to.
deleting it, right?
I don't know. Scratching seems to be destroying the data on it so that it is,
Mm,
it's secure. Nobody can get it.
yeah.
So that's okay.
So I
That's an
don't know if they reuse it afterwards. I'll have to ask them if they reuse it because I'm not sure.
huh. So we're talking about scratching, right? Like that.
Yeah,
I kept saying delete, and he kept saying, no, we're not deleting it, we're scratching it. And so I need to find out what the difference is between deleting and scratching. And if it's
Um.
reused, I'm not sure.
Okay.
I
Wrong
think
kind of.
scratching is like how the way I'm thinking of it is kind of like how Windows deletes a file. They don't actually delete it.
Mm-hmm.
They just change the name of
Right.
it and then
Okay.
make that area available to be written over. We do reuse our tapes. We have after a tape's been used so many times, we automatically retire that particular tape.
Yeah.
Yeah.
Huh.
And
Okay.
maybe that's what they're doing because he said if within 14 days they made a mistake and they accidentally scratched something, then we can recover it. But after 14 days, it's no longer available. So maybe they reuse it after 14 days or they retire it.
Haha. Huh.
Yeah.
Okay. Because I'm thinking about what we call wiping. When it comes to drive, and PC. So when you delete a file, in most operating systems, the data of the file is still stored on the device. Basically what you're losing is the link to where that data is on the drive, but the data is still there. So that means a criminal can go through a drive and just read every single sector there is and try to piece everything back together. And they can do that with NTFS, and I know for sure they can do that with FAT32. because the data is actually still somewhere on the drive. So the process to make things more secure is called wiping. So what wiping does is to identify what sector on the drive is really not in use anymore. And so instead of just losing the link, to those particular sectors, they actually would overwrite those sectors multiple times with random data. So this way, there's no residual magnetic, signature for anything to pick up, and the data will actually be quote unquote gone forever. So I'm thinking scratching a tape is the same as wiping a drive, but I may be wrong. Okay, I have not encountered that particular term before.
Hmm.
So kind of cool stuff. And then number 5 talks about floppy disks. I'm not gonna say anything that indicates other people's age, but I can talk about my own. So I grew up with 5.25-inch floppy disks, and the density of disks have changed over time a whole lot. So basically, IBM invented the concept of a floppy disk, and it was used until at least the 2000s, because I still remember having to install Microsoft Word using like 20 or 30 floppy disks. Um, it's not really used anymore on mainframe computers, I don't think. Simply because the density is really kind of poor and they are not reliable at all. So, um, that's all I have to say about floppy disks. It's interesting. Um, it is removable, okay? Because hard drives, for the longest time, hard drives were not considered removable. Now they are, okay, but not for a long time. Section
That's part
6.
about
Yeah, go ahead.
that's part about the floppy was you could buy single sided and then just with a hole punch make them double sided.
Yes, that was the Apple II computers, right?
I did it on IBM
Oh, so
as well.
IBM had the same thing.
Yeah, the
And
5.25. Yeah.
I had an Apple II clone
Or I'm
computer.
sorry, on a Microsoft system. Yeah,
Okay. So that
that's
has
what I
to
meant.
be the original IBM PC, circa, I think it's 1980.
I had a Commodore 64. It was
A
my first
Commodore
system.
64, do they come with drives? I mean, floppy disk drives?
An external, you could actually buy an external floppy, and they did have a hard disk, but it was really, really expensive. I didn't get that.
I had an Apple II computer probably of about the same time. All right, cool. So number 6 talks about SSD or solid state drives. I personally like to look into how things work. So I looked into that and I found out that the technology behind it is called a floating gate transistor technology. So it's called the FG technology. And interestingly, it was invented in 1960 or somewhere in the 1960s. But it did not became practically useful for 20 years. And can anyone guess why it took 20 years? Well, I mean, the answer to my question is already in the notes, but why did it take 20 years for flash drives or SSDs to even start to exist?
Math,
Sorry?
math.
Math. Yep. So that math, particularly specifically, we're talking about exponential growth. Okay? Does anyone know what is Moore's law? Now, I know this is not specifically mainframe specific stuff, but it is important. Okay, it's very, very important for us to understand Moore's law. What does it say? Okay, so I'll tell you what it says. Basically, what it says is the density of transistors, okay, or the size of the transistor, would cut by 50%. It will halve every 18 months. So every 18 months, when you look at a processor, the number of transistors per area is going to double. That's basically what it says. Doesn't sound that big of a deal, right? Every 18 months, which is a year and a half, we can fit twice as much transistors into the same area. That's basically what it says. So what is the big deal? Well, the big deal is it is exponential. So I'll just ask a very quick question. How many 18 months can we fit in 20 years? That's a division problem.
12?
13.
Oh,
Yeah,
I was
between
just
12 and
guessing
13.
12.
Okay, so, all right, so then I'm going to ask the next question. Okay, in 20 years, how does the density of semiconductor change within 20 years? So we know
Would
there are
be
12
12.
times smaller?
2 to
No,
the 13th
Or
power.
no, 6 times smaller? Because it's half?
no,
Oh,
because it's exponential. It is exponential, right? So what it means is in 20 years, the size of a transistor would be 1 divided by 2 to the power of 12 compared to 20 years ago. So if you think about 2 to the power of 12, okay, 2 to the power of 12 is 1 divided by 4096. Okay, let's call it 4000. Okay, so that means if something has the size of, okay, I'm not going to refer to units, but if we could only put 10 transistors, okay, into a certain area in 1960, in 1980, which is 20 years later, we can fit more than 4,000 that amount in the same area. That is the scale that we're talking about. In If 18 months pass, it becomes 8,000. Another 18 months, it becomes 16,000. Another 18 months, it becomes 32,000, and so on. So this is the game changer, okay? Because it's changing in an exponential way, and as a result, 20 years after that, or 40 years after that, now it is actually doable to have SSD storage devices. Because if we used to rely on magnetic drives or magnetic media, because that has a high data density. But magnetic stuff, okay, cannot shrink like semiconductor does. As a result of that, eventually SSD or solid state technology overcomes hard drive or magnetic technology in terms of cost effectiveness, speed, and also data density. I'm pretty sure most of you have seen a hard drive, okay? Even a modern 3.5-inch hard drive. How many of you put computers together?
I have.
Okay, so have you guys seen a latest generation SSD for personal computers? So we are not talking
Yeah.
about mainframe computers, but the same kind of technology goes into mainframe computers too. So I just want to give you guys a size um, idea of how big an SSD is. You can
I
look
have
it up.
not.
Yeah, go ahead.
No.
So I'm just looking up SSD 1 terabyte, and I'm gonna add a word to it, which is stick. Okay, and I'll just pick this particular Samsung from Newegg. This is what a SSD looks like when you're putting together your own PC, your own personal computer, and it has the capacity of 1 terabyte. It's about 3 inches this way by, I'm gonna guess, less than 1 inch this way, and it almost has no thickness to talk about. It's the same thickness as just a um, circuit board. That that is the size that we are talking about when we talk about a SSD drive. All right. So how what is the comparison between this and a typical 3.5-inch drive? A 3.5-inch drive is 3.5-inch widthwise, but it's longer than 3.5 inches. This whole thing, the width is 3.5 inch, and it has almost no thickness to talk about. Now the price is, this one is kind of a little expensive, but they're catching up. Okay, so SSD technology is now catching up with magnetic media, and I would not be surprised at all that very soon we will only use tapes for backup purposes, and people won't be using actual hard drives anymore because SSDs will basically supersede regular hard drives. Any questions about all of these sections? Because we are basically done with this module. No questions? All right.
Not at this time.
Sorry?
Oh, I said not at this time.
Not at this time. Okay.
Not.
All right. So I'm not really too concerned about whether we understand the actual technology behind all of this stuff here, but when you finish reading the entire module, okay, the one thing that I want you to take away is technology moves in a very, very fast pace. There's nothing that humanity has seen that progresses faster than the semiconductor technology. All right, I can give you an idea. So let me use a spreadsheet to illustrate this. So what you're seeing is just my local spreadsheet, and I'm going to show you Moore's law. Okay, so we are talking about Moore's law. Computers were invented at the end of World War II, which is 1945-ish, and today is 2021. So in terms of just years, right? So now we want to compute, the difference in terms of years between these two. So we say, okay, we got 2021 minus 1945. So 76 years has passed since, quote unquote, the end of World War II. And now we want to calculate how many 18 months are in 72 years. So we take this and we multiply it by 12 months because there are 12 months per year, and then we divide it by 18. So there are approximately 50 Moore's law cycles. So now we look at the actual magnitude change because of these 50 years. This is just referring to the density of semiconductor, but density also affects cost effectiveness. It also affects speed, performance, and a whole lot of things. So we are really talking about 2 to the power of 50 in this case. So we are talking about 1.78 times 10 to the power of 15. That is the magnitude of change in 76 years in terms of semiconductor technology. I mean, if semiconductor existed in 1945, that is basically the kind of change that we'll be seeing. Do you guys understand what is the magnitude of this number?
No.
Yes? No?
Oh, I
Okay.
don't.
Okay, that's okay. Because this is not a normal number. Okay, so this number is basically saying it is the same as 1.78 times 10 to the power of 15. Now, what does that mean, right? So if I were to write this number not using, this is called the scientific notation. So let me see if I can change this not to use the scientific notation. So I can go to Format, and then change number format, and then change it back to a normal number. This is the magnitude that we are talking about. Just count the number of digits.
Dang.
Yeah. So
Is that 1.78 exabytes?
It's okay. This is not a measurement unit. This is a magnitude change.
Right, but whatever that would be, because I'm thinking meg, gig,
Yep.
tera, exo.
Yep. So we have kilo, mega, giga, tera, and yeah, so it's a huge number. The easier way to put this is it is 1,787 million. That is a huge magnitude. And the thing is, if Moore's law can keep up, there are certain physics stuff that kind of limits, how far we can push Moore's law. But if Moore's law is to keep up, okay, we're still going to see doubling the density every 18 months. That is really fast, right? And this is also why, we are looking at IBM mainframe computers, and it's just interesting to look at a modern IBM mainframe computer. It uses the latest semiconductor technology, and yet it maintains backward compatibility, so that any program that is written in the 60s, okay, you can still run it. Okay, any operating system that IBM had back in the 60s, you can still run it. Any data in the format from the 1960s, you can still access it. So that really is very interesting to me, because you don't see that sort of thing in personal computers. I mean, just tell me how quickly Microsoft abandons its standards and its products. I mean,
Every
that
couple
Off.
years.
Yeah.
exactly. Who is still learning Visual Basic these days? Nobody, because nobody, it changes so quickly. But how many people still? The state still needs people to learn COBOL, right? And
Yeah.
the state still needs people to operate mainframe computers using, guess what, technologies from the 60s. So we'll get to that part in other modules. I'm just looking at the time here. It is 7:33, and I need to know how much time I have. So maybe I should move on to what I need you guys to work on before um, the next time we meet, which is Wednesday. All right. So what I have done is to go through this particular module, and there's another module here, which I think is useful, because this is not the sort of stuff that IBM would put together for you, is to understand the historical or background information about what you're learning. This is a homework assignment that I would like you to do before we meet again on Wednesday. And this is the module in InterSkill that I want you to participate before that time. So I'm just going to go to the module so you know which one we are talking about. Can I assume everybody has access to InterSkill?
I do.
I do.
All
I
right.
don't know if Jennifer does.
I
Okay.
do, but I think when I signed up, they said I could only use it for like a year or something like that, and I'm past that year, so I haven't been in it recently. But I'll double check and let you know.
Okay. So go ahead and double check, because from what I have, from the people that have talked to, InterSkill should be available to state employees pretty much universally. So if that is not the case, then I need to know about it. And so depending on whether you guys still have access to InterSkill, I might have to change the deadline of the homework assignment. But this is the module that I want you guys to kind of complete before we meet again on Wednesday.
We have access, but ours it has to be approved before we could
Oh,
get that class. Like it goes through a training coordinator system where we send
oh,
and it needs to be pre-approved.
okay. If you will excuse me, I'm gonna say crap.
Oh,
Because InterSkill actually has really kind of useful information on this. So I'm going to go to the module myself, okay, so I can at least show you what it's going to look like. I'm pretty sure most of you know sort of what it looks like, but I do want to show you that. All right, so if I go to my courses,
Mhm.
I just recently completed that. So I signed up for a lot of stuff, but I don't have time to actually go through the stuff that I have signed up for. Let's see. I think it is this one. So I got it done already. Introduction to DFSMS.
Right.
So when you get to the module, it should start with this. All right. So it sounds like we might have an issue. So I'm gonna have to talk to a few people to see what I can do to arrange for these modules to be available to you. It might not be a whole lot of, I may not have to do a whole lot, because when we say we, we're talking about ARC. We talked to Interskill, and we told them that we would like to eventually open classes like what you're doing right now to the general public. And then we asked Interskill and go like, okay, if we get to that point, would Interskill be interested in a partnership with ARC so that our students would be able to access Interskill but without having to pay a whole lot of money? And Interskill came back and basically said, "Yeah, sure. I mean, we can just give your students free access to Interskill courses when you start to offer those classes to the general public." So I think it may not be a whole lot of steps to get you guys to be able to access Interskill. However, the problem may not be with Interskill. Even if Interskill says, "Yeah, sure, you guys can go ahead and access our content," I'm not sure whether I have to get through the state agencies so that you guys can can actually access it. So can you go ask your
All of
apprenticeship?
us at CDT have access, so it would just, and then Lupe said he has access, so it's just Jennifer.
Okay.
Yeah.
Well, I have access to Interscale, but the actual class, it's not in my portal.
Yeah,
Ah.
Oh,
you
you
have
can, once you're in there, Jennifer, I think you can just search and then add any classes.
you have to search for the course because
Okay.
it's not
Well,
preloaded.
that's
Okay.
what.
I can show you how to do that. That part I can show.
Yeah.
Give me a second here. All right. So what you need to do, okay, once you sign in, it's going to be here, right? This is the usual screen that you see when after you sign in.
Right.
So what you need to do is there are several ways to do it. You can go for enroll for courses and stuff like that. But I found the easiest way to do it is to go to IBM Digital Batch. And this is an interesting page also because what you can see is most of the classes that I would use in this course would also be a part of a batch. So if you just take a few additional modules, you'll be able to get an IBM batch. So with this particular one, it is under IBM mainframe storage, and it's going to be under data management using DFSMS. So once you click on this link here, now remember all of this is getting recorded, so you don't have to do this on the side, trying to catch up. So once you get to this part here, it will have a long list of courses. I don't need you to take every single one of these. I just want this one. So I just want the third one from the top, which is storage dash managing ZOS data using DFSMS constructs 2.3. And basically the first module, introduction to DFSMS, is all I need for now. So it's not. I mean, it would take you a little bit of time because there's a lot of terminology involved and some explanation of DFSMS. But I don't think it's going to be taking you like too much time to complete the first module, which is an introduction. Um, so do you guys think this is doable?
Yeah, I checked my access. I can get back in. So
Okay.
Yeah.
Excellent. Okay, so I'm going to assume that you guys still have access and be able to access this particular module. So the current plan is to complete this by 5:30 on Wednesday, so that we can talk about it.
Okay, and then I also saw that you had posted a quiz for DFSMS that we need to do by
Yes,
Wednesday.
yes, I
Okay.
did. So let me get out of student view.
Where do we wait before you do that? Where do we find everything that you're asking us to do now by Wednesday on our student view?
Okay, so let me get back to the view here because it still has the same items listed. This is all you can see too. You can see every single one of these. I'm not hiding anything. Um,
Mm-hmm.
so this is the quiz that I'm talking about. That I cannot remember who was talking about.
Kelly.
Kelly. So this is what Kelly is talking about. This is a Canvas quiz. Now, don't try to do this quiz on its own, okay? It's going to be painful if you are to do this on its own. So don't do this on its own. So the intention is to do this while you're going through the interskill module. Because as you go through the interskill module, open up the Canvas quiz, so-called quiz. It's not really a quiz because there's really no time limit, except it
Okay.
has to be done by 5:30 on Wednesday. So you can start now and just kind of hang on to it. Don't submit until 5:30 on Wednesday. So the idea is the terms that I introduce here. Okay, I can open this up so that you can have a preview of what questions are being asked. So the questions being asked are basically almost all about what is the full name of an abbreviation. Okay, what is the full definition of? So it is DASD. So I stand corrected. It's not RASD. It's DASD. And then there are some that are multiple choices. That will ask you what a particular module inside the FSMS would do. So don't try to answer these questions on your own because it's going to drive you crazy doing that. I know it would drive me crazy. So instead of doing that, what you want to do, what I think would be helpful, is to go through the interskill module and have this quiz open on the side. So you basically have these two going on side by side because the sequence of the questions in the Canvas quiz coincides with the introduction of those terms in the interskill module. So I basically just want to have my own Canvas quiz to help reinforce the concepts so that you guys would go like, oh, okay, so the interskill has its own quizzes, so you have to do those too. But I have my own on the side, so this way, you're going to go like, okay, so this one is going to do this. So it's basically a way to help you absorb the content so that you have kind of like a double exposure to the concept introduced in the interskill module. Is that
Okay, and
okay?
then
Go
yeah,
ahead.
and then you don't need any because we'll be doing it simultaneously, so you probably don't need like us to screenshot the results from the inner skills quiz, or do
Um,
you want that?
I want that, but I haven't set up a Canvas activity to collect that just yet. So I
Okay.
think for this one, I'm not going to collect the screenshot. Instead, I'm just going to use this particular quiz for grading purposes.
Okay.
But I think you should still be completing the quizzes in the module because, as I said a little bit earlier, if you complete a few more modules, you'll be able to get an IBM badge. So it is beneficial to you, to have completed those modules inside the interskill module.
Okay.
All right.
Mm-hmm.
All right. So I think we are running out of time today. Is that right?
So those are the two tasks that you want us to do before next Wednesday. Okay.
Before this Wednesday.
Or this Wednesday, yeah. Okay.
Yep. So this class is going to be, there's a lot of content to go over. So my choices is basically, do I go over the concepts a little bit more, or do I go over the IBM specific terms more, as we go over this? So the modules that I write, are definitely more of a background, general type of thing. And then the interskill modules are far more IBM specific. So I think, with these two, we can kind of get through all of the content. But I'm going to, I'll be asking you for your feedback on Wednesday to see what you feel about the interskill module because I want to kind of gauge whether it's too easy, too difficult, irrelevant, or just about right. Okay, so you
Now,
don't
what
have to.
about the book that we received in the mail? Do you have like assigned reading that you want us to have read up to before the next meeting, or is this going to come later?
That is a very good question. I'm embarrassed to say I
I
really
know you
don't
got
know.
thrown into this at the last minute. I understand.
No, no, no. It's not even because of that. This has to do with my own personality.
Oh,
um, I personally don't read books. Not from cover to cover. I try to get things done. When I need to understand something, I will go look up something, and that's the only time I'm going to read something. So I don't read things in a sequential way nor a prescribed way. So I think, at least for now, okay, for now, when I'm still teaching this class, the next professor may be doing things differently. So for now, at least for DFSMS, you might want to use the approach of, oh, DFSMS, these modules is referring to VSAM. I have no idea what is VSAM. So at that point, you might want to kind of look into the books or just kind of search online and find out just a little bit more about what VSAM is. I'm just using that as an example. Okay,
yeah. I'm looking at the book, and it looks like the first little section is all about DSFMS, SMS.
right. But the book also goes into a lot of details. If there's one thing
Mm-hmm.
you can count on, is IBM does not leave details out.
Yeah.
It will give you a truckload of pine needles, but it doesn't really quite do as well as a job, telling you how to put the tree back together again. So you might get lost.
Amen.
Yeah,
I was gonna say that's been Lupe's complaint from the beginning, making us read these IBM books.
yeah, and this is also partially why I personally do not use paper books, because it's just not possible to read an IBM Red book from cover to cover. There's just no way that I can do that. I mean, maybe you guys can do it, but I certainly cannot do that. Um, so what?
We've had to do it, but we didn't like it.
No, it's like in one ear and out the other. I'm like, good
Exactly,
lord.
because it doesn't give you the context. It gives you all the IBM terminology explained by IBM experts to what they think IBM experts. They
And
don't really
selling IBM
cater.
product.
Sorry, go ahead.
And selling IBM product, it feels like sometimes.
Mm-hmm.
Well, they do. It depends on which one you're talking about. Some red books are highly technical. So they are not really selling you anything. They're telling you the low-level details of IBM products. Others, yes, I have read a few chapters of certain things. It's like, wow, this looks like a extended commercial to me. When there's no competitor in the field, it's like, why
Yeah.
bother? Because you're the only game in town. Um, yeah, so I totally understand that, but it is also true that IBM documentation tends to be like super duper dry, and they don't establish context of their stuff. It's like, why are we talking about this? Why is this relevant to me? And I
Oh,
think
you're only going to be with us for a month? Darn.
well, this class, I mean, this really should have been a longer class, but we can't fit the content into a longer class. So that's why, we are kind of compressed. But everything said, Interskill does a really good job, okay, explaining things, in a way that IBM could not, kind of stringing things, relating things together. So Interskill does a fairly good job with doing that, and that's why I think it's a very good resource. But even with Interskill, it's not interactive. It is just a module. It's interactive in the sense that it gives you these quizzes. Sometimes it gives you a video to watch and stuff like that. But there's no interaction like what we are doing right now. So that's where I come in. Where I can I will ask you guys. Okay, do you guys have any questions about this? And or do you have anything that you want to tell me about how your agency get things done? So I can take all of that in and try to relate the content from IBM and also Interskill to what you need to do or what you need to know to finish the apprenticeship program. So that's why this is going to be really kind of interactive. So the schedule, as I said, is very tentative because I kind of want to know what you guys need and at what level you're at. Okay, so I don't try to push too much technical content, and yet at the same time enough content to help you with the rest of your apprenticeship program. So when you're
I
reading
have
through, going through the all of this stuff here, you can jot down questions, you can write down suggestions, and let me know how this is going right now. Is it too fast, too slow? Is there enough technical content? Too much, too little, and that sort of thing. So that way I can kind of know where we are, and then I can plan out the rest of the next few weeks, accordingly.
Awesome.
I have a question real quick.
Yeah, go ahead.
Um, on Wednesday, are we also starting at 5:30?
Yes.
Oh, okay. The reason why I asked because I physically go to work Monday, Tuesday, Wednesday. And
Oh.
Monday and Tuesday I work from 7 to 3:30, which is okay. I could when I mean our class doesn't start till 5:30, so I have at least 2 hours
Mm-hmm.
in between. But on Wednesday I work from 8 to 5.
Oh, so you may
So
not have enough time to get back home. I am
uh
I'm okay with changing the schedule a little bit, but it depends on the rest of the class too. So I'm gonna send out another email to see if people are okay to change the time a little bit. So when do you think you can get back and be ready for class, Jennifer?
5:45 will give me enough time to come home,
Okay.
Uh
All right.
15 minutes.
So we can see. I will see if we can change the time frame to about 6 o'clock, just to give you another 15 minutes. But it kind of depends on the rest of the class because it might push up against somebody else's limitation of how long they can stay in class. So I'm gonna do a separate survey. You guys don't have to tell me whether it's okay or not right now because I don't want to kind of get into the privacy issue thing. So I'm just going to send out another email to see whether it's okay to change the time from 5:30 as a start time to 6 o'clock as a start time or somewhere in between. Okay, so we
Would
can
that
give or
just
take.
be on Wednesday that we would do that?
Go ahead.
I think Wednesday is only my issue, but like I said, this Wednesday I'm gonna try to drive home as fast as I can.
Well, don't do that.
No, be safe.
Still make it by 5:30 here at home. I think. I mean, it's just 15 minutes away from my board,
Okay.
but just for me, it's like too close to class time. Like you only given maybe 5 minutes to get ready, and that's it. And then I want to
Okay.
give it time to eat dinner.
So, Jennifer, um, you can also check with your employer to see if it is okay for you to leave a little bit early because this is technically work. I mean, this is part of the apprenticeship program. So you can check with your supervisor to see if it is okay. If it's okay, then you can go ahead and just leave work a little bit earlier and get back home so that we can start the class at the same time. If not,
Okay.
then we'll go ahead and do a survey in this class and see if we can start the class a little bit later. Does that sound
Okay.
okay?
I could probably ask them if I could come in an hour early, like 7 to 4,
Okay.
change my schedule.
All right, that might work.
I'll talk to them on Wednesday.
Okay, so keep me updated. So this way I can decide whether to send out a survey or not, and whether to change the start time of the class or not.
Okay, I will. Thank you.
All right, sounds good. So I think we are out of time today, right?
Yeah.
Yep.
This was a great start. Thank you.
Well, thank you. All right, this sounds pretty exciting.
Yeah. Okay, so we will see you Wednesday and you'll let us know the time.
Yes. So before, hopefully, it depends on when I collect all the information. So hopefully before Wednesday, I'll be able to confirm when the class is going to start, or at least conduct a survey if we need to change the time.
Okay.
All right. So I know you guys are ready for dinner. So, so
Thank you.
thank
Thank
See
you.
you
you.
Wednesday.
Yep.
Okay,
See you on
have a
Thank
good
Wednesday.
you.
Bye.
Bye.
Bye.